we finished the last video, our task was to take each one of these 7 different occurrences of our original shape and try to describe it via the way we got to it most simply from our original shape. Now that's a little bit easier said than done with the 3 going across the top row. And that makes a little bit of sense because these were the ones we found first by simply picking up the sheet of paper that contained our doodle of this drawing and rotating them. Now what I have written down already in my Excel worksheet might differ from what you have in front of you, and that's okay. The reason that we have this discrepancy is that we're talking about picking up a sheet of paper and rotating it. And we have an orientation to rotation, which is, did we rotate clockwise or counterclockwise? Because I already had these set up in an Excel sheet, and I wanted the degrees of rotation to increase in a sense, I decided to rotate counterclockwise. And in that sense, I described this first image right here as rotating by 90 degrees, under the assumption that when I say rotation, I mean in a counterclockwise manner. You may have decided to go the other way, and that's totally okay, but for consistency across the class, let's all decide right now as a class, when we say rotate your image by 90 degrees, that we're going to rotate counterclockwise. And that way, what you do at home and what I do in the videos will be exactly the same. In that sense, on the one hand, I could have viewed this image as rotating it once by 90 degrees and then rotating it again by 90 more degrees, or I could say that more simply as take the original and rotate it 180 degrees. And last but not least, I could consider this last image as a 90-degree clockwise rotation, but to keep with my convention of all rotations being done counterclockwise, instead of calling this a 90-degree clockwise rotation, I'm going to call it a rotation by 270 degrees. Again, I have full faith that whatever you wrote down at home was some version of correct, no matter what you came up with, even if you had a different system for identifying these things. But in order for us to be consistent, let's just adopt these naming conventions. Things get a little bit dicier when we move down to these things that are reflections. For example, when I go from my original shape to this shape, we can see very nicely how I reflected it. I reflected this shape across this line. Now, if I had a physical sheet of paper and I were moving it, what I would be doing to move this shape to this shape would be moving it vertically. However, I've reflected it across a horizontal axis, and so you'll sometimes find people fighting each other over what to call this motion. Is it a vertical flip or is it a horizontal flip? For reasons that will be made clear when we start taking a look at some of these other things that I'm going to call flips, I'm going to call this a horizontal flip. Now, that means that the word vertical flip is available for the other flip over here that I could get via reflecting my original shape across a vertical axis of symmetry, which physically, if I were moving a sheet of paper, would be a horizontal movement of my sheet of paper, but let's call this one right here a vertical flip. That leaves just these 2 shapes right here to describe in terms of how we obtained them from our original. And remember that I really think the easiest way to describe this shape is to say, well, first I rotated my shape 90 degrees counterclockwise, and then I flipped that shape horizontally. But that's a description of how I obtained this shape in 2 motions instead of 1 motion. So I have to be a little bit more clever when I talk about a succinct way of going from here to here. So let me highlight some cells in Excel for you to point out exactly how we obtain this shape from this shape. Across my square, I have this diagonal. So if you look more closely at my original shape and this shape, what you'll see is that this shape is also a reflection. It is a reflection of the original across this diagonal. Now to me, that diagonal looks like the line y is equal to negative x if I kind of take my square and break it into a Cartesian plane, which is a really familiar action to me as a mathematician. So what I'm going to do is call this shape right here flip by y equals negative x. And you can take a look at the other diagonal of this square, and you can compare it to that image. And notice that this final image that we have over here is one that we obtained from our original shape by reflecting across this diagonal, which I can envision as the line y is equal to x. So that's what I'm going to call this motion, flip by y is equal to x. Again, you may have come up with other nomenclature to describe these things. It's not standard in abstract algebra, but these are the words that we're going to be using as we set about our next task. So the last task that I want to do is make what's called a Cayley table for these motions. Remember that we found these 8 motions by picking up our little doodle that had the square and the symbol inside, and we moved it every single possible way we could imagine while picking it up with the square in one place, moving it all around, and putting it back down so that the square matched, but the picture on the inside maybe didn't. We listed out all possible things we could do to the paper, and these 8 things were there. When we combine those 2 things, it tells us that if I first do one of these motions to the square, and then do another motion to the square, well, I need to get one of these possibilities since the square will still map to the square, and these are all possible ways that the image on the inside could look given we're moving the square around. So if I pick up any 2 of these motions of the square and combine them, I'm getting something that could be described more simply as one single motion of the square. And so what I might want to do sounds a little daunting at first, but I would like to make a big old table of all possibilities. So what I've done here, I've created a list of a shorthand for all of the different motions we had in the previous tab. And I'm going to copy this and paste its transpose right here so that I can make a big grid. And what I want to put on the inside of one of these is what happens if I do this motion first and then this motion second. So as an example, when we were back in this page, we said if I first take my original shape and rotate it by 90 degrees, and then after rotating by 90 degrees, I pick up the paper and do a horizontal flip, I'll end up with this motion, which we were also calling a flip by y is equal to negative x. So I'd come on over here to my table, and I would say in row R90, that was the motion I did first, in column H, what I should write here is y is equal to negative x. So the task I'm assigning you is to fill in this entire chart, and we're going to put it into the course log so we all have it to reference for future use. Now that sounds like a daunting task, but I want to give you a little bit of a hint, and that is that it's actually going to be a whole lot faster than you think, because the process of filling it in is going to be very enlightening. You're going to start to see patterns and make observations that will allow you to fill this in very quickly, and that's the thing that I want us to talk about as a class. The only thing I'll tell you before you start it is that you do need to be careful. One of the immediate shortcuts that students want to take is to fill in everything above this diagonal and say, aha, I only have to fill in half the chart. Everything that goes below this line will end up just being what it is reflected across this line. In other words, they think that it doesn't really matter which motion you do first and which motion you do second, that you should get the same answer. So I would just like to go back to our visual examples to show you that we're not quite that lucky when it comes to patterns. So we filled in what happens if I first rotate by 90 degrees and second do a horizontal flip. Let's go back over here and say what happens if I first do a horizontal flip and then take this shape and rotate it by 90 degrees counterclockwise. In that case, I'm going to come up with this visual right here, which is a flip by y is equal to x. So over here, what I want to fill in is when I first do a horizontal flip and then rotate by 90 degrees, I get y is equal to x. And so these two values are not the same. So you're not quite that lucky with the patterns, but you will find patterns that will be good observations, and we'll talk about those patterns in the community log and also in person.